Okay, so let's learn the other phase of El Nino. We said El Nino is an anomalous situation where the trade winds get weaker for whatever reason, or the West Pacific warm pool gets pushed eastward for whatever reason, and then you end up having these ocean atmosphere feedbacks where the reduced upwelling makes the temperatures warmer in the east and further reduces the sea level pressure, further makes this pressure gradient weaker, SST gradient, sea surface temperature gradient weaker, and so on. La Nina is the ENSO cool phase. El Nino, remember, is the Christ child associated with God. So you cannot call the opposite phase anti El Nino, right? Obviously. So the name La Nina came along, which is a very cute name as well, which is the colder phase, which means you follow through the same sequence of events. Increased pressure difference across the equatorial pressure. Somehow the process starts somewhere, so the eastern Pacific cold tongue becomes colder than normal. The sea level pressure becomes stronger than normal, pressure gradient becomes stronger than normal, so winds become stronger than normal, stronger trade winds, stronger divergence, stronger upwelling, further cooling of the sea surface temperature, further increase in the sea level pressure, the further uplifting of the thermocline, so shallower thermocline, and more nutrients, higher biological productivity. Very nice, right? So this is how the sketch looks. We are now looking at stronger coastal winds, stronger than normal trade winds, more than normal upwelling, uh, colder than normal sea surface temperatures, higher sea level pressure in the east. The West Pacific warm pool, which is being pushed further west, is becoming warmer. So it's smaller and warmer, more rain, anomalously higher amounts of rain in the west. Obviously, again, Hadley cell changes, Walker cell changes over the Indian and Atlantic Oceans as well. So again, you get global teleconnections. Okay, so places like California or North American coast and South American coast actually become drier because of this colder water. That's another thing to remember. If under global warming the East Pacific becomes colder because of these feedbacks, then California and South America could become drier. Why is this important? Right now, as I'm recording this, California is having catastrophic uh, wildfires everywhere. The largest area ever burned in modern era, and there are records in the past history where civilizations, Incas, Mayas, basically went extinct because of these persistent droughts. One drought or one flood doesn't make the civilizations run away, but if they keep on happening again and again, then civilizations have no more water. They try hard to do water harvesting, fog harvesting, and so on. If it doesn't work, they have to move or go extinct, right? The Vikings went extinct, for example, on Greenland when the Little Ice Age came and pushed them out. Okay, so here, colder temperatures extending further westward. The upwelling is stronger, so the thermocline is shallower. You can compare this to the normal conditions we saw before. More confined, heavier rains on the west. Only thing I will add is that the El Nino related impacts around the globe are not exactly the opposite of La Nina related impacts around the globe, because the impact of moving the heat source eastward during a El Nino and pushing it further west during a La Nina are not exactly the same in terms of how the Hadley cell changes and how the Walker cell changes and so on. But nonetheless, La Nina also has impacts. For example, the monsoon in general tends to be weaker, more droughts during an El Nino in general, not always, and La Nina in general, not always, tends to bring more rainfall. So this year it was forecasted to be a La Nina in 2020. We thought monsoon may get stronger in August, September, but right now we are in a break and we are expecting more rain. So La Nina tends to bring more rain to the monsoon region, and El Nino tends to bring less rain. That's the story of La Nina, the opposite phase of El Nino. Make sure you understand both things in terms of what the ocean does, what the atmosphere does, and what the feedbacks are. These positive feedbacks, which means one change leads to another change which reinforces the first change, is called a positive feedback. They happen during both El Nino and La Nina. Make sure you understood it. Okay?